Okay, as I looked at our journey, I wanted to see if there's any historical context that I could refer to. And I think there is. So this is lights out manufacturing. And, this is machines building machines. And this is actually where we want to go with incident response. But manufacturing didn't start this way. In the beginning of the industrial age, manufacturing started with a steam engine, and a steam engine driving a single shaft. And the machines were linked to that single shaft. And then the electric motor came along, and what did we do? We repeated the same thing. We created a giant electric motor, and we attached the machines to that single shaft. And does this sound familiar? When ChatGPT came out, if we didn't want people to copy and paste data onto the web, what did we do? We created a single portal for everybody to use within the team. The real industrial revolution happened when we started to decentralize this. So we actually used the electric motors, separated them out. Now, that evolution there took 40 years. There wasn't any technical thing stopping it. It was people, processes, the designs of the factory that were wedded to this old design. People weren't envisaging a new factory. When I go through this talk, what I want you to do is think about where you are on this journey. Are you looking at the old? Have you decentralized your AI? Have you now got it into this automation system where these decentralized is now integrated with these other things? Because that's the sort of journey that we achieved, or we're on at the moment where we are. So as I said, I'm Ben. So I work for the AWS Security Incident Response team. And what we do is we help customers on their side of the shared responsibility model. Now, we've always been doing reactive, i.e. customers telling us they believe they're having a security incident, but something we wanted to do was be more reactive. So tell customers they were having a security incident before they even realized they were happening. Now, both of these evolved, and I'll talk about the first bit, which is the reactive side. So i.e. customers telling us. If we look at how we handle customer incidents, we can break it down into these different sections. It's initiated, whether the customer comes directly to us, which they can, or whether they raise a support case and it comes via the support teams. The first thing we need to do is triage it. Is it actually a security incident, or is it actually operations or some other issue that they're facing? Then we do the investigation. And then after that, after it's all contained, and we create a report. And you can see the approximate time frames of those activities. Obviously, how long is a piece of string in terms of these, but these are the sort of ranges we can say. If we take the triage pit, we were challenged with two areas. Firstly, inaccuracy. Was it actually a security incident? And secondly, the lack of information. And, we need to absolutely find out straight away if this is a security incident or this needs to go to another team. It's just because it's not a security incident doesn't mean it's not urgent. So when we looked at this, and in terms of, our considerations for AI, it was time critical. It wasn't really the time to put a chatbot in front of the customer. There's zero tolerance for error. We could not deflect any cases that were not security incidents. We had to make sure they were. And, did AI make the responder better or faster? And that's a constant question I'll be asking throughout this. And the question I'd pose to you when you're considering AI as part of these. So our solution was to have Incident Commander, which is an AI triaging bot, do a bunch of searches in the background based on the information provided by the customer or the support engineer. In the meantime, the human is looking at this and interjecting if if there requires some sort of interjection as part of it. So we weren't putting any AI in front of the customer, but if at the same point we could look at the information provided and know that Incident Commander will handle this correctly because it's dealt with these before. And you can see there wasn't a huge time savings, and that's why this decision was made in terms of that for the triage. The investigation, the fun bit. Now let's go back to the primary tactics of threat actors. Really, there's three major things. There are other things, but these are the three major things we see. We see resource hijacking, your typical crypto mining. We see ransom events, i.e. people wanting money for their data, and we see opportunistic vandalism, people just destroying things. My anecdotal feedback is developers who haven't been paid. So pay your developers. Okay, all of this falls into what we call that zero trust strategy. Remembering that, anybody, that threat actors don't hack in, they log in, they're after the credentials. What can those credentials do? And don't forget, it's not just humans that get credentials, it's services that get credentials. So, on the premise that each of these credentials may be compromised at some point, what is the impact of that? That is, in a nutshell, the zero trust strategy. So let's look at a simple resource hijacking. This is the one I see the most often. So simple email service. So basically using the AWS simple email service to conduct spam operations. Facilitated by an access key being compromised. It's always access keys, and I'll come back to that. The kill chain is quota increase, create an SMTP user, and then fire out the spam. And typically the customer's being told, because we're notifying them, that they're getting lots of complaints about spam notifications. I'll come back to the access key. As I said, this is the single thing that threat actors want the most. I'll give you an example of, what I say to everybody is, please don't use access keys. I'm a hypocrite, I use access keys, but I don't use them in production. Yeah? Don't use access keys in production. We had a customer who had 80 access keys on a private GitHub repository. Can you guess what the intern did? Yep, they made it public. And these were exploited within minutes, and the customer couldn't rotate them because they're business critical, so it's a fun day for everybody involved. Now, personally, I think the intern, provided some really good, security process correction there. The CEO didn't quite agree. Anyway. Overnight, if you consider that was the kill chain that we're seeing, overnight, what we're seeing is far more complex chain of events. Now, the red lines there represent the spam operations. And what you can see, all of those gray pieces are dormant persistence. And if you trace it back, from one of the spam operations, let's say at the top, it's been created by a user. That user's been created by a Lambda function. That's further been created by another user. And you need to trace back to patient zero. Because what you need to do is trace back to patient zero and then trace forward to make sure that you're removing all of that persistence. There's even an API gateway in there, which is another favorite tactic of threat actors, putting them in there, leaving them 90 days and not invoking them for 90 days. Why 90 days? Because that is the logs that you get free, the management logs you get free as part of the AWS. If you don't choose to bring them together or keep them longer, you're not going to know who created that API access key and therefore be able to trace back to patient zero. Now, I'm not saying this is AI, but it was remarkable how quickly the threat actors evolved in terms of their tactics and their procedures and their ability to create persistence within the environment, just on the provision of a compromised access key. And as you can see, the time involved in that sort of investigation manually is far more complex. You really have to go through a fine-tooth comb to do that. So in terms of the investigation challenges, we need to know who patient 0 is. We need to know it's contained. We need to know all those dormant persistences are removed, have all the resources being cleaned up, and can a customer actually clean this up themselves, or do they need a script to help to clean this up? And we were already on this path, in terms of we were seeing more and more complex kill chains, and what we determined was actually it's better to create a Python script because this is deterministic. And what AI did do is because we were creating a bunch of persistent scripts, i.e. patient 0, and then providing persistence, and then which resources were created, etc. A bunch of Python sort of scripts. It took us, we created 4 in the same time that we created 1 using AI, and that's where it really helped here. We wouldn't use AI to necessarily go and look at the logs, because as I said, it's deterministic, but creating the Python scripts to do that rapidly increased our capability. And as you can see, by running these scripts, we could really get down the time in terms of ensuring the customer is contained and it's cleaned up, and we're giving them scripts in terms of cleaning up their environment, etc. And I put this seasoned developer to clean up the code. Again, code reviews are getting better and better by AI, but we're still, employing seasoned code professionals to really go through, the stuff that we've created. And then the customer report, so the last bit. And AI absolutely nailed it. Absolutely reduced the time. Again, we'd be very strict in terms of telling the AI what to do. We'd have report templates. It would only go from our knowledge base, i.e. previous correspondence that we've sent out to customers, or AWS documentation. Wasn't allowed to veer from that. And even then, even with these strict guidelines, every now and again went a bit crazy. So, create that feedback loop, have a human read it. And what I mean by create the feedback loop is when you like it, feed it back in, give it a higher priority, and so on, because the advice also evolves as we go along. So the customer report was a real time saver in terms of the use of AI as part of it. So that was our journey and is our journey in terms of the reactive side. In terms of the proactive side, i.e. we are telling the customer, what we're doing is taking the customer's alerts and trying to find, and the way we describe it is, we're not looking for the needle in the haystack, we're trying to remove the haystack. So we're looking for known good. So what do we do first is we group together the alerts in terms of the resources, in terms of certain things that we have rules about. We then remove those if they're related to a non-security event. After those have been removed, we can push it onto a further investigation that looks out wider. We're looking at other customer cases. We're looking at the customer cases that this customer's had before, if they're related, and we're also looking at our threat intelligence. Again, gets rid of a whole load. And then we have the human review. So the ones that have passed all of these filters and come through to the human review. So we still have the responder at the end of this. And we're constantly reviewing those ones that have been dismissed and the true positives and so on. And also the false positives that come through will feed that cycle as well. But in terms of AWS, we obviously talk about this 2-pizza team. So every team is the size that could be fed by 2 pizzas. We're talking about American pizzas, not the European ones, or that'd just be me. Because of that organization we have tools in all sorts of places. Which is a good side and bad side. So it encourages lots of innovation, but it also means as a security investigator, you're having to jump to different tools and context switching. So we built a responder bench, the MCP. So it's reaching out to these different tools rather than making the responder having to go out to these tools. It's bringing that information together. And so we're looking at, it can straight away look into the logs of the accounts that's impacted. It can research against the threat intelligence that we have. It can look at our documentation. So it's building all of that, and a daily basis, we're adding new tools, we're adding new processes. If we see a new type of compromise, we have instructions on how you work through these logically and so on, and that's constantly building our team. Everybody is submitting changes to this workbench as it evolves. Anybody can do that. It gets reviewed by various parts of the team and then just gets submitted, and that's a constant evolving process. And as an example, and we had a talk about the supply chain attacks. The first one, the trivia alert. So within that window, in terms of it was reaching out to a C2, and our tools said this is a false positive, because at the time the DNS is resolving wasn't marked as a threat, and the hash of the software wasn't marked as compromised. 2 hours and 56 minutes later, that had completely changed. So we needed to retrospectively go back and actually look at these. And this tool was able to look at 51,000 alerts in 12 minutes. And that's the accumulation of these alerts. And we found 4 other true positives. So 4 other customers that we went out and told them they may be impacted by this supply chain attack. A real game changer in terms of the ability to work with these different tools, work with these different things, and bring it together, and the speed at which it can do it. Okay, so the takeaways, and this is probably one of the most controversial things that AI's done. It drew me a pizza with pineapple on it. Okay, so firstly, I want you to consider as part of this where, don't think I'll plonk AI in front of the incident responder. You'll notice I've never said about replacing incident responder and so on. It helps them along this journey. It's not creative, but it can guide them if it has the right guidelines to be guided by. And what we did here is we broke down each of these stages, and we thought, where can AI help? Whether AI is helping building the tools or AI is actually helping in terms of the output, think of it in that sort of stage. That's how we thought of it. Also think about where you are on this journey. Are you still on this sort of, the electric motor but the single shaft? Are you federating out these workbenches to your teams? Because that's absolutely key as part of this. Everybody knows their area really well, and do they have those capabilities and those things to build within their area to actually get the most out of what they do, the efficiency in their job? And if that's not the case, and it's being held back, let's say, by security, let's talk about what are the things that can go wrong. Really, when we explain it, there's 2 major things. One, the AI tells you something wrong. That's where we will always have somebody reviewing it. There's the example of Air Canada where they had to compensate a customer that's told something wrong by a chatbot. So it can tell you something wrong. The other thing it can do is it can tell you something it shouldn't. So if you're training that AI tool on data that you don't want shared, you shouldn't be having that AI tool out there available to people who shouldn't be able to see that data. Nobody's been able to stop that yet, so I wouldn't be comfortable. Having a tool exposed that's trained by data that you don't want exposed. Again, that solution already exists. All of the cloud providers, lots of providers out there that can provide you your own virtual private server AI tool, which keeps all of the data inside. So, if there's a security side to this, I would argue this is not the greatest risk. The greatest risk at the moment is the threat actors aren't bounded by business cases, they aren't bounded by procurement strategies, etc. They're using these tools, and you're sending your defending team into a gunfight with butter knives. Okay? So I'm really passionate about this because, if the Ukraine war has taught us anything about, the changing battlefield and all of that, we need to be giving all of our teams the ability to innovate. Some of our most junior teams are coming out with the most extraordinary tools, which are giving us that upper edge against the threat actors. The other challenge, and this is a great article, anything by Tim Harford's a great article, but this is about the automation paradox. And, you know, a lot of the level 1 early lifting stuff is being done by the AI. So how do you train your next generation of responders? And, you know, the example in this article is an automated car. Hands over, when it doesn't know what to do, it'll hand over to the human. Now, the human may have never driven a car at this stage, so how do they know what to do? You know, very much the same thing here. So you have to think about how are you bringing on the next generation. You know, we always have them in the loop. We have them doing manual investigations, learning that art, we have sort of environments, you know, for them to test and do all those things. So again, think about how you're bringing on the next generation of responders or whatever it is where you're using AI. Because that automation paradox is, you know, how many of us remember phone numbers, for example? We've outsourced that to our phone. And finally, you know, I've been in this game for a long time. The amount of change, the speed at which it's coming is absolutely, you know, I'm feeling it, everybody's feeling it, so don't feel like you're alone in terms of how quickly everything is changing. So, you know, please don't panic. You know your kids who can, you know, use a remote better than you can. It's not because they've read the manual, it's just because they've messed around with it, okay? Go and mess around with AI, have some fun, learn from it, and see where you can actually bring it into your pipeline. Thank you very much.